say literally just run this process. It could be Java, it could be LS, it could be Bash, it could be any from the smallest script to the biggest Prism type platform. I literally say run this process, and when I run it, that process now sees its own file system as well. I'll go into it in a second. They have some optimizations which makes that very inexpensive. So one of the great things about choosing Linux as the platform for Docker, it only supports Linux, and because it only supports Linux, okay, you had a question?
I'm just wondering, so how is this different from like a Linux user instead of root, like a specific user running an application? Because he's going to have his own resources, his own file system. I'm just trying to understand how this is different from that.
So perfect. So the goal of Docker is not really security. So when you think of containers and zones specifically, you think more in terms of putting limits on the process and more around security.
Right.
The goal of Docker is actually not that. It's kind of just a side effect. But the goal with Docker is to create repeatable application packages that can be deployed and run consistently on any Linux system. So I can take a product and it can have any number of libraries. It can have just, I can maybe rely on MySQL, install MySQL, and I need this library and a photo conversion or an MP3 encoder, and then I put Java on there and with a bunch of files or whatever, and I literally create what is effectively a virtual machine, and I save the state of that machine as a virtual file system. And then I can go on any Linux system that has the Docker toolchain and say, run this app. And so the cool thing about this is, Docker currently only runs under Ubuntu. The toolchain only runs under Ubuntu, supported today. But within my host Ubuntu system, I can tell Docker to run a program under CentOS. But this is not virtualization. It's not booting a CentOS machine inside Ubuntu. All it's doing is it's mounting a CentOS file system and then running my program on top of that. And that's a huge, huge difference because really, if you look at all Linuxes, Debian, Ubuntu, CentOS, Red Hat, they're all binary compatible operating systems. They're all using the same Linux kernel. A binary that works on one will work on the other. The only thing that sets those distributions apart is, Red Hat does configuration one way, Ubuntu does config a different way, so the way you set up your network or manage users or all the utilities that come with the distribution are different. But a program that runs on Ubuntu, I'm sorry. Yeah.
Well, I guess the packages are different too, right?
Yes, but again, package management is just, it's all about laying bits on disk. Right? If I run apt-get or yum or deb, they are sophisticated systems in how they go out to the internet and resolve dependencies. But at the end of the day, they're just putting bits on disk. Once the bits are on disk, they're binary compatible no matter what. I mean, it doesn't matter if I got wget by running yum or running apt-get. The point is, I now have I have a program on my computer that I can run.
Okay, but those programs on the computer expect shared libraries to be in certain places, which can vary by operating system, right?
No, exactly, and that's why so that's why you have this layered file system.
Okay.
So and I'll show you guys in a second. I'll put my screen up there so I can introduce some concepts. In practice, what does this look like? What I did was I installed Ubuntu on my machine. And I got the Docker toolchain, and someone had already created a CentOS base image for Docker. So I say Docker install CentOS base. And what that does is it goes out to a Docker repo, that's a central repo, and it looks for an image called CentOS and downloads that. And what the image is, it's not a virtual machine like you would expect, like a VBox image or whatever. It's literally just someone installed CentOS on a clean machine, like absolute minimal base CentOS, and saved the file system of what that install looks like. Of course, there's some things you need to do to get networking to work right. There's some scripts you got to put in a root directories so that Docker can set up the network, virtual network and stuff like that. But effectively, it's just a snapshot of a vanilla CentOS. So when I say Docker base install CentOS, it's basically just downloading this tarball on my system, and then I can say Docker run some command, but I want you to run this command inside that base image. So what it does is it creates what's called a container. So Docker actually, all the fancy stuff that Docker does, it's not, Docker didn't do it. I mean, these are all kind of very proven tools within Linux. The primary one it uses is called LXC. So Linux containers. It's existed for years, and then it uses a virtual unioning file system called AutoFS. So Docker is really just a tool chain around these two things. So I'll just show you guys right now. I can basically install the CentOS base image and then run bash. I can literally just run bash inside that base image. And then once I was in a bash shell, I could do anything. So what I did was I ran the Amici chef recipe. So I downloaded chef and I ran chef and it went through the whole install successfully. And then I exited out of that bash shell, and what I was left with was now this basically a file system that had CentOS with Amici layered on top of it.
Okay.
So what's the difference between this image versus just get a VirtualBox image?
You don't have
VirtualBox CentOS.
the virtualization expense, right?
Yeah, you're not paying for virtualization. Like, if I run Prism inside this CentOS base image, I can go to the host operating system and do a PS, and I see Java running. Like I see.
I can see that.
Oh yeah. It's one OS, one kernel, one thread scheduler, one memory manager. It's just it kind of takes some while to wrap your head around it, but basically that process is running under. It doesn't see my host file system. It just sees this base CentOS file system that's clean and is unaffected by the changes in my host environment.
It's kind of like turning the kernel into kind of like hypervisor.
Yeah, that's exactly what it is. It's.
Dave, can I ask you to maybe move to your right or something? Because I'm recording this and I
You
want to
always okay.
I want to record. I want to be able to get this display. Thank you.
I thought you always.
I was telling you to move. I just do it.
Right.
I just do it because
Not enough right wingers here.
Oh.
All right. Yeah, so I'll show you guys quick here. I got so I'm in Ubuntu right now. So this is a VirtualBox. So yeah, I don't want to confuse you guys. I'm running Ubuntu in VirtualBox on my machine because I needed an Ubuntu box to play with Docker. But forget that it's VirtualBox. Just pretend I'm on a bare metal Ubuntu system. Right. Let me make this speaker thing. All right. Can you guys see that? Okay.
Can you
Yeah.
make it the font a little bigger?
Yep.
Thank you.
Cool. So I could go Docker. Oops. Sorry. All right. All right. So I have a bunch of images that I've downloaded. So these basically. So here I have CentOS 6.4 base image. Okay, and so I'm telling you, all that is literally someone installed CentOS and took a snapshot of the file system. There's nothing special.
So you couldn't the Linux kernel again?
It's the whole file system. Of course, the kernel doesn't actually get used. There are a bunch of files there that are probably you can clean up afterwards, and they actually have a guide for creating your own base images. If you want to reduce the size, there's a bunch of things you actually don't need, because again, all it's looking for is like configuration and settings files and things, shared libraries that are assumed to be there by the environment. But of course, the kernel's never going to get used.
What about the user space, like the user accounts?
You can create users, although when Docker runs, when it runs a process under there, it's running under
The host.
it's under the process actually running under the host under root as the host, but then within that container you can sudo. I mean you can do anything you want within there because of course the permissions are being enforced based on the file system and what's in that local password file and all of the different settings that are within it. I'll show you in a second. Yeah, so they have some examples here.
But assume that basically your image and the host has to have same version of its kernel.
Yes, that's right.
So you cannot have
What?
far apart. Because you cannot have one version of Linux kernel in host and then another version in image.
That's right. I mean, you can have any version of the kernel you want in the image. It's just not going to get used. The programs are going to run. The programs are going to run. All the programs are running on the host. There is no running in a container. There is no. Yeah, it's literally. You have to start thinking about it. It's literally just a creative way of using file systems to emulate.
You just mount the file in the system.
They literally just mount the file system and then run the program on the host. And you'll see I'll run a program inside what looks like CentOS, but I'll go back to the host and you'll see the program's just running in the host system. I mean, it's so here I'll run through one of the examples here.
The container file system basically overlays on the host, right? So you kind of like a filter.
Yeah, I mean, so this is the most basic example. I mean, it's I don't even know if it's terribly useful, but just to show you that it's working, so I can do. Yeah, so I just ran this command, and what this command did was it told Docker to mount a CentOS, create a new container, which basically just it mounts this base image, and then run this command bin echo. Bin echo hello world.
Usually cat etsyresolve.com or Etsy Red Hat dash release. That might be a little more.
Okay, yeah, cool. Yeah, so cat.
So you don't have a path. You have to
Hmm?
in the host when you run a command in there. There's no like path.
Right, you have no path variable or anything like that because again, it's a new environment.
Is there just out of curiosity? Is there a concept like a dash profile of bash RC? So when you go into the environment, you can have it set up.
Yeah, so that they have a run list. You can basically have a kind of like a vagrant file, but you basically say anytime you run
Anything.
this image, go ahead and set these things up.
So if it don't get into this container, you just run all the things outside
Mhm.
the host.
Yeah, you run outside. Now I'll show you something cool in a second, but so bin cat.
Etsy dash Red Hat dash release.
Right, so it thinks I'm running
Yeah.
CentOS. Now I'll show you something cool, right? Yeah, and again, straight out of their examples here. Go to a more complex example here, but.
It's only Linux.
Because there's only one real OS.
Right. So here we go. So run CentOS bin sh. Sorry, I'm just trying to remember the command here. It was the detached mode. Sorry. Commands. Run. Okay, yeah. Okay, cool. Yeah, so Docker run CentOS bin sh. Sorry, guys.
Yes.
Okay, yeah. And then this is running in the background, right?
I think that has to go before.
Yeah. Right. What the fuck? Oh, that's a shame. Yeah, cool. So you'll see I ran this command. I ran the command right here. And basically I said, just run bash. And I said, run it in the background. So keep it running. Keep it running after the command finishes executing. And what it did was it returned this ID. Right? So now I can do this command, docker attach. Docker. Oops. Fuck. Probably should have had my demos ready. Alright, give me a second, dude. Alright, there we go. Right. Sorry, I was missing I for interactive. Alright. Sorry about that. Let me just delete the stuff we don't need. Yeah, and I'll show you guys in the doc why I have to do this, right? So if I go to commands, run. Yeah, so I do need to do I, because otherwise it's just going to run the command and not leave a standard in session open. So it's literally just running sh, the shell, and then the shell completes. It's like, hey, it ran, but it's never attaching any kind of input, so the command just ends. So I do -I, it'll keep the input open, and you'll see I'm in a bash session right now. So if I go to Etsy, I'm in a CentOS, what looks like a CentOS box right now.
Can you run
Red Hat release, CentOS release. It's got RC files. It's definitely not Ubuntu.
sysctl-a? Sys sysctl -a. And those are although that will be the kernel properties from the host OS, right? Not from like if I increase the max files in Etsy sysconfig limits.conf inside the CentOS VM, it wouldn't have any effect here, right? You
That's
can't
right.
modify this.
That's right. Yeah. So for those types of details, what you'll want to do is you'll want to go to the docs for LXC. So LXC is the jail. It's a kind of a cheroot container environment, but of course more advanced.
So like
Yeah,
John said, does it like go through the like a profile file and set up the man path correctly? If you just say a man or any command,
Yeah.
does it show the man page of these containers?
Yeah. So I don't think the man command is probably even installed, but I can do yum install man.
Okay.
That's cool.
Oh, okay. So you attach into it. You install it to the file system.
Yeah. So I'll show you real quick. I'll install the man file, and so one thing to understand here is I'm running bash based on the CentOS base image. The base image is never modified. So what's actually happening now is it's using this special file system to say, go ahead and mount the CentOS base image, but overlay any writes that I make get overlaid on top of the CentOS base image. So you'll see right now when I quit this container, so I'm installing man right now, because this is very minimal CentOS. I mean, it's literally just like bare bones. Like I think it is like the minimal install. So even basic things like man aren't even installed. All right, so now I have the man command Yeah, you can see.
df-k. Let's see what kind of file system it has here.
Yeah, so you can't read the mounted file system.
Why not?
Cool, because it actually requires that you have access to low-level access to the kernel to even know what type of attached storage you actually have. Now, things like DH, of course, work. Well, if I had it installed, things like DH work, but DF doesn't.
Yeah.
That's the command that.
What does df-k show?
I think that's what he just.
Just.
Yeah, that's what I ran, and then it says cannot read
Okay.
table of mounted file
Right.
systems. Yeah.
I missed that.
So hold on, let me just SSH history. Let me start another shell session with my Ubuntu with my host just to show you guys something.
How about network? Run the if config. What
Oh
would that
yeah.
show?
Do they all have the same IP?
Yeah, it will be interesting. Show if config.
So it doesn't have a separate process for the CentOS. It just basically it's a set of tools to allow you to run a program with it.
Within that file system.
Within the policy.
Right.
Yeah.
Yeah. Well, but then that's some trickery that Docker does with AutoFS, but it is also running in an LXC container. LXC is a kernel module that allows you to put limits on a program. So it also has kind of paths features where you can say, okay, run this program, but only give it 16 megs of RAM and only this percentage of the CPU. So it does have virtual
Which
machine,
program then?
the one you're running. So in this case, it's Bash. Bash is the program I'm
Yeah,
running.
but if I run several programs, then
Well, they're part of a process tree.
Okay.
Yeah. So I mean, you have a base process, but of course that process can spawn other processes. And in the files, for the kernel's perspective, it's a process tree, so it all spawns from one.
I can start multiple bash here from the host, right? Do
Yeah,
they share
so-
the process tree?
No, from the host. Yeah.
Right.
yeah.
So they don't. So then when I say I only use 50% CPU,
Mhm.
it's per process or per
Per process tree.
per process tree.
Yeah. Yeah. Per container, technically. Yeah.
That's kind of the vSphere feature.
Yeah. So here I'm in the host
So
right
each
now.
process running its own container. Each process. So I start 5, bash from host.
From the host, not the guest.
Then I got
You're saying in Ubuntu. In Ubuntu, I run the Docker command 5 times.
Right. Then I got 5 containers.
Yeah, 5 containers.
Oh, okay.
Yeah.
Okay, so whatever you change on one session doesn't actually affect
Completely isolated from the other one. Yeah.
Okay.
Yeah.
Interesting.
So right now, if I do a PS aux,
Can you set priorities across containers? Not hard limits, priority.
yeah. So most of the limits are actually priorities. They're weights,
Okay.
weighted.
Relative.
You can set absolute. But actually the default is to have it be weighted.
Okay.
So I can say, these 5 containers are a weight 1, these are weight 2, these are weight 3. So you can see, Bash is actually running right now as user 1000, which is under LXC.
Okay.
Ifconfig, you guys asked about ifconfig. Ifconfig works the way it normally does.
But the network interface is showing the host network interface.
No. It has its own bridged interface. So here in the container, it shows up as ETH0. But if I run it on the host, you'll see I have a Docker bridge with.
Oh. Okay.
So Docker includes the network
Mhm.
kind of resource. Okay.
And
Yeah.
none of the ports are shared.
Hmm?
Like if you're listed on
None of the ports are shared. So that's an LXC feature.
Okay.
You have your entirely different port space. Because it's running under a different interface. Basically, what this is right here is it's a bridge, and there's nothing fancy about that. I mean, I can do this. You can look at the Docker source code. It's literally just running this command IP. It's just running IP and then setting up a bridged interface. So all Docker is just there's nothing really low level about it. It's Docker is just a set of scripts that help you manage things that Linux does already, like setting up bridged interfaces and routing tables and things like that. LXC is probably the most experimental of all of them, but even this has been around for 4 or 5 years.
I think it's older than that.
Hmm?
I think LXC is older than that.
Yeah. I mean, it was kind of in research mode for years, but
So, Jose, what is the application? Where can we use this? Is it going to be useful for us?
right. So where I see the big opportunity is in basically what I did with Amici. I'll go into that container, but it's basically using Chef as part of our release process to create containers. But then on site with the customer, or in our hosted network, you just deploy containers. You don't actually have to run Chef on each server. You run it once, build the image, and then you just deploy the image. And of course, you can rerun Chef to apply configuration. The config management is actually a separate topic. But a lot of the challenges we have in the field, like with dark installs and all this stuff, is how do you lay the bits on? And then as an ongoing challenge, it's how do you do config management. Docker doesn't solve the config management problem at all, but it does solve the problem of how do I get the bits down in a way that's repeatable and consistent. Chef gives us the repeatability, but it's a pain in the ass because you have to run it on every server. It requires internet access, things like that.
So
Also with Docker, you get the flexibility of being able to run it on any Linux. So we say we require CentOS.
Right.
Customer only has Ubuntu. No problem. Install Docker, run Prism under CentOS. Without the penalty of virtualization.
have we run any load on these?
No, I haven't. But there isn't much that you would pay a penalty for. You could even disable all the guards in LXC. If all you're using it for is for packaging, you can disable all the limits on here, and what you're left with is really just a very lightweight process execution and this file system. And I'll show you the file system. I mean, it's not a virtual file system in the sense that it's like a VBox hard disk where it's a big file on the host.
Yeah.
It actually is. They're just files. I'll show you. Look, var.
Can I interject the meeting we had this morning to Raj's point? So AT&T has these 5 environments: dev, stage, UAT, all running that they use to support things they're doing. We only care about production. We're trying to do an upgrade. The guys from AT&T, from Black Flag, are saying, oh, well, we need to test this before. We used to have a dev install. Can we just bring that dev install back up and reinstall 11.6?
Mm-hmm.
I mean, if we had something from when we originally did the install, an image, then when they bring down their environment, or intentionally or unintentionally, being AT&T, that we could have just...
Yeah, that's another great point too. Yeah, it's not just how do we deliver our own software, but you can snapshot a working environment that maybe they need to reclaim the server, or maybe they just need to shut down the machines. You can,
Cloud sucks.
yeah, but you can literally just snapshot the environment with an actual deployment configuration, and just as long as you just store the file somewhere, you can always bring it back up, and but that's you can do that with VirtualBox. You can do that with any virtualization. The whole point is you get the benefits of the kind of appliance model without the overhead of virtualization. I mean, I'll show you right here on the file system. So, I think showing the file system here. It's not a virtual file system. See, if I go to var lib docker, you'll see here I have a thing called containers. These are my different containers. And I can literally cd into one of these. They're just files. This is my overlay file system. So I could go into the read-write directory, dev. So here, let me actually use a docker ps. So let me actually go into this one so you guys can actually see, because all I did. So this was the CentOS base image, and then I think we installed man on it, right? So what we should see here is just what yum install man produces on disk. You actually won't see CentOS. You'll see literally only what that yum command produced on disk. So I go here. We go to the read-write directory. And so we do ls etc cron daily and man. I guess cron daily got created when I ran yum. Etc user lib yum plugins. I guess something needed Python, or I guess it's just the site packages, right? So you can see here that just running yum actually produced a lot of shit that actually wasn't directly related to man. But here I could just do a find dot, so you can get a sense of what's on disk right now. It's mostly just stuff related to me running yum probably for the first time. But I see all the man stuff. So man created this cache file and a bunch of yum stuff or whatever. But the point is, this is not a CentOS box. It is the delta between the CentOS base image and what I just installed.
Yeah, there's something about that. Like, what did I read? I can't remember. Still, something about upgrades in Docker. The way it gives you upgrades or something. Like you only have to ship the difference, right? Like, if you have an Amici image, can't you only ship like a CentOS and then Amici? You have two images at that point, right?
Yeah, it just depends how you want to package it. I mean, you can stack base images. You can have more than just one base images, right? So you can have the CentOS base image, and then you can have the kind of Voxeo tools or Tropo tools base image that's derived from CentOS, and then on top of that, you can have a Prism apps, Prism base image, and then you can have Tropo provisioning and Tropo runtime and an Amici provision. They all use Prism. And we want our command line tools to be on all of them. So you can basically stack these base images, and that way when you create a new container, you just say create a new Prism container, and you already have Prism deployed and it's installed, and you just lay the files down that are on top of that. So I've proven that it's not a virtual file system. They're just regular old files sitting on the host. So from a performance perspective, you're not really taking that penalty. Another cool thing is that everything on the CLI, so the Docker command itself, wait, I'm in CentOS right now. But this command itself is literally just a client to a Docker REST API running locally on the machine. So everything you can do in the CLI is actually all part of a REST API. So things like creating images, running commands inside an image, backing an image up, compressing.
So there's a Docker process, right?
There's a Docker process that has a little web server, and it's just taking commands from the CLI. But of course, you can automate everything programmatically just by interfacing with the web server. And actually, this one guy, Docker. Yeah, this guy created a project. He literally implemented the OpenStack API as a proxy to the Docker REST API. So basically any tool that was designed to spin up OpenStack images, OpenStack VMs, is now compatible with Docker because you basically tell OpenStack, hey, spin up a new VM with 16 megs of RAM, but it's not actually creating a virtual machine. It's literally just doing Docker run, CentOS, and then with some configuration with how much memory and what the network config should be and stuff like that. So there's already a lot of work in the community to create some compatibility between a lot of these IaaS tools, infrastructure as a service tools, but using lightweight containers instead of virtualization.
So I see the benefit, in the development or simple POCs, because it will make it run quicker, right? But in real production, it's going as native as possible, right? There's no need, why do I need more layer? Even though it's probably too small.
Yeah, well, so Dark installs is one. Basically, repeatable deployment is the argument. I mean, if you go to the Docker website, they don't talk about security or anything like that. Again, basically what they're saying is portable, self-sufficient containers for any application. And the whole point is to have repeatable deployment. We use Chef for that. If we didn't have Chef, of course, it would be maybe a different story. So today we have Chef, and it's like, okay, well, Chef is supposed to give us repeatable deployments. Personally, I see Docker even in production as a way to solve some of the challenges that we have with Chef in the field.
I'm really curious to find out, like, load test it. I know we see everything says lightweight, no overhead, but do we really get the same density that we get in production? Like, if we do,
Right.
There's no reason not to use it.
Yeah, I mean, and again, easily done. I mean, you literally just create a bash session inside a container, run the Tropo Chef install, and you've got a Tropo server, and you can load test it. I mean, and
How do I define the networking? Like, how that VM? Like, how did it get? How was
you
that?
need to get you put the VM first.
I have
Yeah. So the way you do the network is, so you when you run.
I have the Docker already installed.
Yeah, so when you do Docker run,
Ubuntu virtual.
when you do Docker run,
For real load testing, you need a bare metal Ubuntu. Then run Docker on bare metal.
Well, we can actually, I could
Right.
do it on the plane, make the gateway and runtime on my machine,
Yeah.
and then image it, and then go get bare metal.
Right.
Yeah.
That's true. You
It's
can
nice.
build a container anywhere. I mean, that's actually a better test. Is build the container locally and then literally just transfer the image over to a bare metal server and do Docker run.
What is image? Just simply just copy the file system.
It's a zip.
Right.
Bar.
Yeah. So they have a what's called a public registry. They called it their index, so index.docker.io, and you authenticate with GitHub, but it's not pushing the files to GitHub. They have their own index, their own hosting for it, and you can share your containers. It's like a social thing. You can share your containers, but internally, I mean, obviously, you probably don't want to be uploading Tropo containers up to the internet. You can just literally just package up the container into a zip file. And
You can make your own, right? You can.
you can have your own private index.
Yeah, some guy at the users group.
I think it's just a couch database or something like that.
Oh shit! What was I gonna ask? Wasn't there something? There's a couple of projects that are like. They're like using Docker right now. I can't remember their names. But they're like UIs on front of Docker or something like that. Do you know anything about those?
Well, there's CoreOS.
No, CoreOS is the replaces Ubuntu, right?
Right.
Okay.
Yeah, there's this project too. I mean, if you're gonna you probably don't need to get fancy with the networking. I mean, you basically you get an interface and then you just like in VirtualBox you do port mapping. You tell it to map the ports. But if you're doing performance testing, you probably want a true bridged interface. And that's what this guy has created. It's literally just a single shell script. I mean, you literally don't even have to use this script. I mean, it's just a nice convenient tool. It's like 120 lines of bash. But basically, what this does is it tells LXC to bind a native bridged adapter to that container. And then what you end up with is literally it's a bridged network. You get a new DHCP address. You get your own IP on the network and stuff like that. That's what I had to do when I was setting up Amici, because containers can't talk to each other out of the box.
Oh.
They're on their own. When Docker runs a container, it's in its own virtual network. But so using Pipework, basically all it's doing is running the command IP. But what it's doing is it's saying IP, create a new bridged adapter, and then there's a special command to LXC to say, okay, make this adapter visible to this container and just magically appears
And there's
inside
no
that.
overhead
And
tab, right?
then to there, then you don't have any overhead because it's not port mapping at that point. It's literally just a bridged interface, just only visible to this one process.
We should try this. Shits and giggles at the very least.
But yeah, that's kind of
But what about? I mean, if we did this, or even if we played around with this, like we've never run Prism. Well, you have with kernel 3.1 million, right? Like a lot of unknowns there.
yeah.
What's the kernel version of Sonos 5?
2.6
Yeah, this is 3.8.
light years.
Yeah. I to be honest, I didn't have a single problem with any of our recipes, which I was really excited about. Any of our chef recipes. I did run into issues with like installing Clearwater IMS. It relies on IP tables persistent. It's a Yum package. IP tables persistent, and it tries to load a kernel module. And in a container, you're not allowed to load custom kernel modules, and so it fails. So it's not a perfect setup. I mean, you really do at times will probably have to tweak your software. I mean, luckily for us, I mean, the big question mark for me was VCS, and VCS ran fine. And then Java, of course, is very less of a concern because, well, Java just kind of does its own thing, and so it is a virtual machine. Yeah, so I was actually pretty pleased that our stuff just ran out of the box and it worked.
How do we do the real deployment? It's always kind of depends on config, right?
Yeah, so if you right on the Docker homepage, they just made an announcement last month.
Right.
So Red Hat is starting. Red Hat, they're smart guys. They're seeing how popular Docker is, and Docker's based on Ubuntu. So they started showering them with resources now to get Docker to run on Red Hat Enterprise. They're targeting Fedora first, which is kind of the kind of but it's more of their kind of leading edge distribution. But of course, they say
Wait, this is tools I was talking about: Dice, Flynn, and Box.
Yeah.
Sorry.
But yeah, no. So they're already saying, they're saying that they want to reduce the dependency on AutoFS because it's kind of considered an experimental file system, and there's apparently better ways of doing it inside Red Hat. And then compatible with other kernel versions already.
What does it need from 3.8 kernel? Like, what's in 3.8 that's not in 2.6 specific? Probably plenty, but what is it specific?
It's not Docker. It's LXC that has the dependency on it.
Oh, LXC doesn't work in 2.6?
Yeah, I don't know.
Oh.
But, yeah, that's what I had read. Yep. So, anyways, I mean that's that, guys. Yeah, I don't have a crazy demo. I mean, this is but I was just surprised with how well it just works. I mean, the project is good. It's well documented. There's plenty of examples. There's a big community around it. No, the question is the real question is it useful enough? Does it solve enough problems for us to justify an investment in testing and time and all of that? And it seems like you guys already have a good plan for the Dart install. So if that's not an issue anymore, then maybe we have repeatable deployment already, and you guys are doing that.
I can see this with people can start using this kind of development. I want to install multiple things because our software always require multiple nodes.
Right.
And they install multiple things.
Right.
Another ops code is they're not using Docker, but they are using LXC for their CI. It's like insane. Like it took a second for him to spin up that container,
right,
rather than 2 minutes to boot up a VM,
right,
which is really cool.
Yeah.
And then you can also test. They use it to test. Like every config path in their cookbooks or whatever they're working on, because they can do it check out, make an assertion, instantly roll back, try try nat mapping in the config.xml, and then try adding, file interfaces.
Right.
It took them a long time to do it, but
Yeah.
they were.
I mean, in our case, we'll spend most of our time waiting for Java to start, or for the Prism AS to boot. 25 seconds or however long it takes.
Could we, just out of curiosity, could you snapshot with the AS? Oh no, because it's in the host OS. It'd be cool if it was already running.
Yeah, no. Yeah. There's none of that. It's not a virtual machine, so there's no snapshotting kind of memory state. It's all
It's only
files.
snapshotting the files.
Yeah.
But
Okay, so
the form factor is kind of like a soft appliance when you deploy.
So you're
Yeah.
realizing
I mean, that's how I like to think about it. I mean, it really is kind of a lot of the benefits of the appliance model, but
Yeah.
with almost none of the overhead.
Got to start learning Go.
Yeah. Go and Docker, we're set. Let's just rewrite everything.
Yeah, Kenny, we need you to rewrite Prism. In Go.
In Go.
Go. Now. Are you done yet?
with the store itself.
You either can't
It's easier, just change the Prism combiner to Go.
Ah!
Yeah.
Problem solved.
Go AS.
Yeah. Oh, yes.